first question. Who has an accurate list of the S&P 500?
I went on Wikipedia.
Yes, there's a bunch out there that aren't all the same.
I didn't get that far.
Yeah, so Wikipedia's got one. S&P. So where have you guys looked?
Oh, I asked you friends for some.
Sorry, what?
What?
I asked some concept about S&P 500 to friends in the economics department.
And they sent you a list?
Oh, yes, but he said that it's easier to credit every.
That it's easier to what?
It's ridiculous to credit. Ridiculous to credit every return for.
Well, that's why they have the S&P 500, right? The whole point is to weight them, right? That's what they do. They take 500 stocks, 505, I believe, and they weight them. They try to get the best gain, right? But it's not just to increase revenue, but it's also to reduce variability, right?
You said it's a list for.
It's a list.
It's not the best, but it's better than other.
Yeah, well, I mean, we could do it, theoretically, you could do it for all of NASDAQ, right? Right? I mean, there's no reason to do the S&P 500 other than it gives you a defined set to work off of. But that's my question. Do you guys have a list of the 500?
So you're saying it's not the same list?
Well, I looked at a couple places.
I was assuming it was the same. That's why I didn't really.
So it changes.
Yeah.
So the 500 is a general number. So I have in here, I like the Wikipedia one. It has 500. I know where it comes from. I know how it's going to change. And I've looked at 5 different places. So one, there is this GitHub page. Yeah. You guys can look what I'm reading about. S&P 500. Right. Data sets, S&P 500. So, this GitHub page says there's a source file on the S&P website, which there is. But when you download it and look at it, and it says page 4 or whatever, is where the data is. There are a bunch of tickers, and there's about 450, 460 of them. But I'm not so convinced because the sheet of this page is called issues, which I'm I don't know what that means. So although it comes from the S&P website, I don't necessarily trust it. But whatever, so I'm not going to tell you definitively what to use, but I've used Wikipedia, and I just Googled for S&P lists, right? And then a pay, I have no idea what this is, CBOE, but Standard & Poor's 500 SPX, right? And it said this was as of 10/30, right? So October 30th, because again, it changes. And this has 505 stocks. The Wikipedia one has 505 stocks. I just realized today that not all of them matched up. I thought it was gonna be look for the 500 and find them. So I haven't. I can do that right now to merge them, but I was just looking at dimensions. I looked at a couple other places. So one thing I'll suggest, one thing I will say, is that whatever one you choose, I would try to make sure that you get one that has information on the industry, right? So if I look at the wiki tabs, and that makes no sense. That's just what I called it in my variable. So it's got a ticker symbol. It's got the name of it. Some pretty much irrelevant SEC thing. GICS sector. So this is the sector that this company's in. This is the subdivision, where it's located. I don't know if you would actually use that information. And then some other things about the volume and when it was added to the S&P. So I personally think that if you're going to do maybe choices of that to me seems like the type of industry might be relevant. I don't know. Again, the funny thing is if you look at some of the research on the stock market, it's kind of chance. So I don't think that's true necessarily, but I mean, if you talk to some of your friends in economics, they might agree more with that sentiment than what we're trying to do here. But okay, so getting a list. All right. So I mean, again, I'm saying this is more open. So if you guys want to ask questions or something like that, I will talk about quantmod a bit and how I will use it. But I mean, what do you guys want to talk about? I mean, let's for right now say the Wikipedia page has got what we want. Does that sound good to everybody? Yeah. All right. Okay. The only thing I hate about it, it doesn't. Their first column name is like has spaces in it. Okay. This was all crap that I did before I knew what you guys were doing. So, okay. Library. Okay, all right. So we're gonna get data from the quantmod package. And again, I forget that. You guys need to like remind me that this is like the size of like a pea. Like you guys can't. I don't know. Maybe your guys' eyes it's like super good, but I mean I can make it bigger. You get used to it, but I guess I can make. I'm just saying. Tell me when it's small because sometimes I forget. So we're gonna be using the quantmod package. So who's looked at it so far? Just a little bit. You have it downloaded. If you don't, download it. All right. So here's a question. When you're going, you're like, we told you you're gonna use the quantmod package. What do you guys do to kind of like try to figure out how to use a package? I think we talked about Google, talked about vignettes, talked about help files. So to me, Google encompasses all that at the same time usually because CRAN has like I just say like quantmod package, and it'll come up with the R help, right? So this generally is not very. This is not very helpful in the sense this is the same thing if you said help package equals quantmod, and it'll give you this stuff. And if you actually look at the, but it says that, but sometimes it says like code demos, those things I might look at. But let's say okay, so it says all this kind of stuff, and like this format is all great and good, but like it doesn't really help you on stuff. But a lot of times, if they do have a website, it's located in their description file. So this is quantmod, okay? So there's a website. There are examples of what you can actually do, except, you see stuff like this. Model building, July 2008. Like, it doesn't seem like there's a link there. So sometimes I just look at what other people have done, like with some random blogs, that kind of stuff. So like if we go back to Google, right, you'll find this, and it's like, you see quantmod, an introduction. So like vignettes like this sometimes are very helpful. And, I didn't even do this, but this is the way I'll be showing you. I didn't realize that somebody else had talked about this. But I'm going to be talking about today this thing called an environment, right? And I'll be very specific as to why I'm talking about this. This is kind of like a higher level thing in R. So like when you like read something into R, right? You say x equals read.csv. That's located in what's called your global environment, right? That's where like you type x, stuff prints out. But if you like dig into like a specific function, a package or something like that, there can be things defined in that package that aren't defined in your global environment and stuff like that. There can be functions defined in like a package that you can't access. They're not exported. So that's because they're in what's called different environments. And the idea is you can think of them as just big containers, right? They contain variables or functions or whatever. Now, why do you guys care about this? It's because the main function you guys will be using in the quantmod package is get symbols. And if you look at the help for this, say get symbols, you pass it in the symbols. I'm not going to talk about environment yet. And you say like, where do you want it? You look it up, right? All this fun stuff. So get symbol, and you're going to pass in. Let's do this right now. We're going to pass in the first symbol, and it's almost guaranteed to be remarkably not impressive. Oh, it's triple M. It's 3M. It's not A. I think the second one's like A or something like that. But, okay, I say get symbols. So everybody right now, download the quantmod package. Okay? And load it up and say get symbols and then 3M. Steven, I want you to tell me what the price is for yesterday. You get an error. What does it say? That's good to know. That's not an error. That's just a message. Errors are, what is it? I don't know if they're color coded on yours, but like.
Yeah, I'm saying.
They're the color?
They're the same color.
Oh, yeah. Errors say error. So it gives you this lovely thing back that just says triple M. Like, oh, yeah, that's your stock symbol. But if you look at LS, right? LS says list all the stuff in your in the parent environment, in the global environment, in your workspace. What's in there? You'll see this triple M is there. So, okay, let me be clear as to what happened. We said get symbols. We passed in a symbol. It got the information we wanted, and it assigned an object in our workspace that is the same name as the symbol. Right? So if we pass in like AAA, there'd be a AAA object in our workspace. Is that clear? Like what happened? So this 3M object came from the get symbols thing. So usually that's fine if you want to do 1, 2, maybe 5 symbols, for example. Like think of each symbol, and by symbol I mean stock ticker shortcut, right? The name of the stock, as like a data frame. Right? This is a data frame of the open, high, low, close, how many stocks, and I don't know what the adjusted thing is again.
I don't see an adjusted. No, I mean I don't see
You don't see it?
No.
I don't know.
Oh, we may be using a different source. Is that gonna end up mattering?
It shouldn't. I mean, you for the most part you'll be using, at least for this project, probably the open and close. Right? You may use the high and low to kind of determine maybe variability of that stock, that kind of stuff. But okay. Everybody, we got some data for the 3M company. Good? Now, but if you think about it, let's say if you were to organize your data, would you want every single stock to be in its own data frame? Maybe. But you probably don't want it to have to remember the stock symbols for everything else. So, at least the way this specific package is set up, it's set up to throw out that object into an environment. And by default, it throws it in your global environment, pretty much your standard workspace. Everybody good on that? Now, what I want to do is not that. I want to pretty much have a list of all these things where each one of them is named by the ticker symbol. Does that make sense? So let's see, wiki tabs, ticker 1 to 5. So let's say I want a list where it has, for these 5 stocks, each one of them has its own data frame, and I can reference them. Right? Does that make sense? Like a list of these things versus having an MMM object in my workspace, an ABT object, an ABBV, a ACN, an ACE. I want to have one object that I can reference, maybe 3M, ABT, something like that. Okay? So, the way we have to do that in this case, and I'm going to take these out because those are no longer relevant. You say data equals new.env with parentheses. That stands for data is something I'm calling it is a new environment. So when I say get symbols, and it says great. If I say class data, it says environment. Environments don't work like other things necessarily, like lists. Like you type it out and it's like, oh, environment with a bunch of numbers and letters. Like if you actually tried to view the object. So it's not, it won't print out like a list. It won't like print out like a matrix. It prints out a little bit differently. Okay? So the nice thing about this, if I want it as a list, so let me step back. Data, the nice thing about it, I put a $sign and I can reference these things by their stock names. So now it's one object where the names of that object is determined by the ticker symbol. Okay? So if I like type this, I wonder what happens if I just say plot. Probably nothing good. I don't know. Well,
There's a function that you could,
yeah, there's like plot and there's like nice, like super awesome charts or something like that. What is it?
Candle chart?
Let's see.
I didn't like any of the plots. They might
Candle
be
chart.
little. They're all the same too, which is confusing. Like multiple commands get you the same looking graph. Like bar chart or something.
Oh, but look at the colors. There's just so much. No.
You can say theme equals white if you wanted.
No.
White dot mono.
What is it?
White dot mono.
Weight.mono. Well, I mean, so they give you some charts, and it shows you like the volume of the stock, right? So that you could potentially look at this and assess whether the volume is related to the change in the stock. We're statisticians, so we could do like correlations or stuff like that to kind of assess that stuff for at least this specific stock, right? Now, again, we can make it as a list, right? So you say as.list. Okay, whatever. So I want you to notice two different things. One, the names are the same except for one thing. And I want to tell you what that thing is. That just tells you where you got the stuff, right? It's not very useful unless you guys, for some reason, will be mixing and matching which sources of data you're going to be using. Okay, so now we got this whole list of crap. We got all the symbols are in there. So now it's like kind of like a normal list where you can kind of do stuff with. Now, let's say we want to merge all of them together. Right? We want one big master data frame. But let's step back and like talk about what these objects are kind of in our list. So D2 class. So these are not exactly data frames. They're time series objects. Right? So when you say plot on that, it's not just doing like plot X versus Y. Right? It does the plot operation for this type of object. So this type of object, an XTS, it knows that it's a time series object. It knows that you're trying to plot something over time. Right? So if I say, and if you look at the row names, it actually doesn't have any. But if you say like head and you look at it, it's like it seriously does look like row names. But that's not the way this object stores things. So, if you want to read more about kind of how time series objects kind of work, we can do that. You can sample things by the kind of year. You can subset things a very different way than you normally would with like normal objects. You can do it with like dates.
What is the time series object? Which one of these?
This is like for a single stock. That's a time series object.
So we have a list of those.
A list of those. So, okay, stepping back. Have you all used the merge command in R? Right? Okay, I'm just making sure the baseline's there, right? So merge usually pass in like 2 objects, right? Or you can pass in like as many as you want. Now, one of the problems is if I say like merge D2, it's like I got no idea what you're trying to do. Okay? So, there is a different kind of function.
Is that a different package?
Reduce?
Yeah.
No. It is a...
That's weird. Why is it capital R?
It's it's a good question. So this is like a generic type of function in like many languages. So like there are map, there are reduce, there are filter, there's like find. So these are like big things. I will tell you this. I did not use reduce until probably like a month ago in all the R I've ever done. But it's been something that I've actually been looking for a long time that I didn't know existed. So what do I actually want to do with this? I want to take every single one of my data sets and I want to merge all of them together. Right? I want to make a super data set, a super data frame.
Of what format though? Like what would it look like? Or are we gonna get there?
Well, we're going to get there in the sense, so what it will merge on is the date. So when I say a super data set, I mean a super wide data set. Right? Might not be what you want. We can reshape it, right? Which is something we'll probably do. Merge it all together and reshape it. The other options are you reshape it on date, and then you make it long per data set, where like maybe one column is well, no, I'm not gonna say what I would do. What would you guys do? What kind of data do you want? How do you want the data in order to examine? What would be the optimal format for which to analyze this data? And so maybe stepping back, let's talk about how you might want to analyze this data. What's the question? Would stock will return the most percent, the highest percent, right? So how are we going to define percent? Right? It's a pretty straightforward calculation. You either do the close divided by the open, right? So closing price, or you do either one. They're the same thing, just this is this minus 1, right? Because it's close. That's 1. Right? So you either do percent change as what is this stock in terms of what percent, or if you multiply by 100, it's a percent. It's like what percent cost, or how much is the stock worth compared to when it opened, or what was the percent change, right? Now, the one thing nice about the top is bound between 0 and 1, right? Can't go negative. So money's never negative, right? Money is always positive. It always costs something to buy these stocks. They never pay you to buy them. I mean, then you would just win, right? That would be this one can. Right, that can go from actually, I didn't mean. Did I say? If I said bounded between 0 and 1, I didn't mean that. I meant bounded between above 0, bounded above 0, right? Because you could double your stock in a day. It could be 2. That number could be 2. It could be 10. right? That's very rare. Or like if something crazy happened, but it could be like a half, right? In a day, half of the stock's value could go away, right? So it's between 0 and infinity, but most likely in practical terms, it'll probably be bounded in the terms of like no more than probably 3, right? But this has like a different kind of connotation, like a percent change and that kind of stuff. But it's not. It's really the same variable. And for almost all kind of like modeling approaches, it doesn't really matter, right? Because if you think of like if you did like a linear model or something like that, or as long as it's impervious to kind of like shifts in the y, it's not a big problem because it's just a shift by 1. Okay. So let's say that's what we want. Close divided by open. And if that's above 1, it's good. If that's below 1, it's bad. Or if you were trying to do something like, maybe, if we wanted to maybe just do classification, and we did the subtraction, negative's bad, positive's good, right? It went up, or it didn't go up. Okay, so, how would you want the data? Stephen?
You always ask me.
Because I only ask you when you're on your phone.
She's seen on
Yeah, I assume she's taking notes. She could be, hey, like, I'm sorry, I'm blaming the technology completely. She could be writing a fanfic novel about anything, but I'm not going to call her when she's doing that because I'm like, that's a pad and paper, and, like, I know. And it's not just the phone, it's the fact that you have a full-fledged computer in front of you. So I know it's not something like I'm looking up an answer. No. Well, I mean, it sounded like you guys wanted to do that. So I think it's like, what kind of, so y to me isn't that bad because I can just do open divided by closed easily.
All the column names are different.
All the column names are different.
That's why I would want it that way. But I don't know.
But, okay, so
I mean, you can paste the column names.
who's a master reshaper?
That's why I meant just leave it.
Yeah, that's a good point. I will say though that if you can do some basic regular expressions, and I'll go over kind of what I mean by that in code in a minute, then this isn't a problem. Because if I melt this data set, which means, and I say no ID variables, pretty much it's going to just string it out into one very, very, very long vector. And it'll have a vector of the values, and then it'll have a vector of what those variable names were.
What happens to the dates?
So I don't know with an XTS object. We'll find out in a minute. But what I'll actually, I believe if you create, I don't know. I'm not going to conjecture, but I can figure out what those dates are. I can either pick the row name, like even though row names are null, I can find out where that's stored in the object, and I can bind that to the data, right? So then I'll be like, open, close, open, close, open, close, open, close, open, close, and then a column of the dates. Right? Does that make sense? So then when I reshape it, I'll say the date is the identifier. And so then it'll be like date, one row for ABT, open, high, low, close, volume, whatever. So there's a lot of different ways you can do this. Some are more efficient than others, and some are more relevant if you want to keep certain pieces of the data. So let's say I don't care about the high and low. I don't care about it. I don't care about the variability in the stock. I just want to know close divided by open. That's it. I can run through those lists, and I can just say keep the column names that have open or close in it. Maybe keep the volume. Okay? I can do that. Yeah.
So it's simply why it's not in the morning and in the open time or at the end of the day.
So Jeff said that when he wanted to say that if he bought the stock in the morning and sold it at the end of the day, how would you make those profit? Right. Buy it open, so whatever
So
money you're
on the first
putting
day
in.
and the fifth day.
Huh?
So on the first day and the fifth day.
The first day is you buy one day lag. You buy at the beginning of the day and sell at the end of the day. And then the 5, there's two
So what is the best stock to buy for the maximum return?
for 1 day or 5 days.
in 5 days?
So then the 5-day one would be the beginning of the first day and then the end of the 5th day.
So,
That's why
So there would be 2 different like predictions. One, if you're gonna have it just be 1 day. One's what the best stock is for 1 day and what the best stock is for 5 days.
Okay, what's so 1 day, so when is the last day with correct information?
I don't
He-
understand.
He said we would be predicting on the day that it's due, like the day that we hand in the. Or wait, that doesn't necessarily make any sense. He said something like he said something like that, right?
Yeah, he did.
Yeah.
But it wouldn't be the day that it was due. It'd be like the day after it was due.
No, you Jeff would be like 2 weeks.
No, but that's. the
But you
day
should
that
be
he
able.
said.
Your code should be able to draw a
Yeah.
new prediction.
Yeah.
It should be not like a fixed thing. It should be like, okay, here's my criteria. Here pulls the data. Here's my criteria on that data, and here's my pop out saying like this is your top stock.
So our
We-
code is basically the function.
I think he's gonna like run it in the morning, and then he's gonna like run it in the morning and then again at night or something.
No, you'd only run it
Once.
once in the morning, and he would get.
In order to get the
In order to get
the
prediction,
stock that you
and then
want
you-
to buy.
Yeah, exactly.
I remember him saying something, but he was gonna do something at night too. I remember him saying something like that.
So
I mean, what you would actually probably do. You can gauge what the open value is, the opening cost of a stock. But anyway, what you want is this number or this is again one way to do it. You can do. I think percentage is probably the most relevant. But when you're buying stocks, is that the only thing you care about? So you're telling me you don't care if the stock costs $50 versus $1,000 versus like 20 cents. So like in like actual like don't ever try. Not say don't ever try this, but like there are other components to think about than just like the expected return. Right? There are how much does it cost, how much fees do you have associated with like actually buying the stock, how much is the actual stock. Anyway,
but
shares.
he's only interested in the percent, right?
He's
So
only
regardless-
interested in the percent for this project.
Okay.
Well, I think he mentioned that if suppose we have like a certain amount of money, then if we invest the whole like $500 in like any stock, then what's the best way to get the most profit out of it? So if it's cheaper, then
Yeah, if he's only interested in the percent, then I feel like we should just put a higher rate on the cheap stocks because they're probably more available. So
Well,
you can see you probably see more growth.
percent doesn't necessarily matter on what the cost is originally.
Yeah, but I mean,
It's
if
percent.
they're being evaluated, because I think a really cheap stock would have more of a higher probability of having a larger percent increase.
So
Is that true?
stocks under like $1, their prices carry out to like 3 to 4 digits, right? So like Google stock is like 500.8, whereas like a stock under $1 can be like 0.10024, something like that, right? So that's not. So I don't understand. So what is your argument there?
I'm just saying. So if we're going to evaluate ourselves on what the percent increase or whatever.
So
then-
So two things. I think you're saying is that open, because it's a small denominator, has a higher probability of being.
It's
higher.
going to be more available. So if you choose a good subset of really cheap stocks, there's going to be more
Yeah.
availability.
I agree with that. It's
I mean, it
in
wouldn't change
theory,
your
but
model.
not necessarily. And the other thing is, I don't think any of the S&Ps are really that cheap. They're not like.
I guess yeah, that's the piece. Yeah. I mean, yeah, I guess if you were just using all stocks, then you would all just do that.
so when you say you might want to think about other stuff than just like open inclusive.
No. For this project, maybe volume.
What is volume?
Volume is how many shares kind of are being traded.
Why would that be?
I mean, is it related to the change in the stock?
I don't know anything about
Nothing. I just go in S&P 500, what you think?
Yeah, maybe that's something to think about. I haven't really thought about that. Like, now you got like,
well, I guess the point to make would be it doesn't necessarily matter whether or not we know anything about it because you're just feeding it into the model, right? Is that
well, the question
point?
is,
That
my question to you is, does it matter?
I mean, if we put it in the model and we're just doing like machine learning on it, then maybe it doesn't really matter whether or not we know what it is.
Maybe it
because the Kaggle thing, we didn't know anything about anything.
So, like, the volume, does the sector matter? Like, does like the volume matter in like different like health sectors, that kind of stuff? Because if the volume is very, very, very low, which again, these are S&P stocks, that's probably not going to be a problem. That means like nobody's buying or selling, right? Not a lot of trades going on, which means the stock isn't likely to change value, right? I don't know that much stuff. But like, you know, the question is, does like 10,000 shares versus 100? 100,000 shares. Huh?
It's off.
Okay. Versus like 100,000 shares in the market versus like 5 million shares in the market. Does that matter? Right. Again, I don't. If we were talking about the entire stock market, this might be more of an issue than kind of maybe these companies or these stocks. Because they're not out to pick losers, right? In this game, right? They're out to take like really well-performing stocks and to do a combination of them so that they potentially can reduce variability, reduce risk while still ensuring that they gain money. We're not doing combinations in this project. This was the S&P. The only thing about it was to select a subset of stocks from the market, not anything more about how that's derived or anything like that.
Subset? So like not just one? Or
No. Like I'm saying, the 500 versus the 3,500 to 5,000 that you'd have to like explore if you were looking at the entire Nasdaq.
Can I ask a follow-up question about like, variables? So I think where I'm getting confused about this project is, and you might not be the best person to ask, I should ask Jeff, but like, so like the Kaggle stuff, we had all these variables, but I feel like now we're talking about only a couple, and I think I'm confused about how to do modeling with only like the historical percent change maybe, or like the sector, or it's just like, it seems like less features.
Less features. Yes and no. But you have the day before, you have the 2 days before, you have the 3 days before. I mean, so like the features that you really have are the information before the amount. Like, so if you were to predict on a certain day, right, you have the lag 1, lag 2 information on that stock.
So that would be included in the model.
Because it's, all right, so like in general, right, you think of what am I going to have on my test set? And in this case, your test set are the same stocks, but in the future. But you'll still know what the close was the day before and that kind of stuff. But this is always a good thing to think about in like training and testing, because like sometimes you'll be like, this is really important, this variable. And then you'll realize, I may not actually have this for my test set. I don't know, because weirdly enough, in that Kaggle competition, they had like a weighted metric that they ended up using, but that weighted metric was reliant on the actual value of the outcome or something like that. So it was like, you're not going to have those weights. So it's like, just remember and be sure that whatever you're using to train a model, that when you go in the future to actually use it, you're going to have it, right? So like, for example, let's say with the data you have, like let's say you had like just health data about children. And an MD in a clinic who saw all these children made a thing that said like on sickness 0 to 10. I'm going to say 0 to 10 how sick they are. But that's not a standard thing to be done, right? And if you go to a new data set, one, you're not sure that anybody's going to do that. You're not sure that anybody's going to do it like the clinician you had did it, or if they're going to use a different scale, or all that kind of stuff. So the generalizability of your model, of your method, of your results could potentially be very, very small because of a single variable that you used. So just remember, whatever you're trying to do on the test set or on the training data, make sure you can do it on the test set.
So can we talk about what the training data would look like?
Yeah.
I think I'm just confused about how you set that up because we have all this data, but what would you like pick one day and try to predict, like train everything before that,
Okay.
and then predict that day, or
So let's do something very simple. Let's take the rank. Let's take one day of data. All right, let's assume we have just yesterday's opening and closing values for a stock. Right? What's your best guess for the top performing stock for today? Well, it's whatever did the best yesterday, right? What if like this stock yesterday was just a good day? They like said something on the internet that like they're gonna cure cancer or something or whatever, or like they got a new CEO, or state released a new feature, or something. There's variability in that, and not only that, you guys know statistics. There is a lot of times regression back to the mean. So although things can go up, a lot of times they shrink back. Right? That's not always exactly how the stock market goes. But like you don't look at a stock and it's like, it's all smooth. It's like jagged and up and down, and maybe over time the trend is up. So simplest predictor, take the day before the best stock, right? That is a predictor. Now, with this data, you could evaluate how well that did. Right? Just say, find me the best stock from the day before for the 1 day prediction. And just give it. And I'll say that's the best. That's the best.
for the 1 day.
For the 1 day prediction.
Yeah.
And on top of that, what is your estimate of my percent return? It's going to be the same as yesterday because that's all you have. But now let's say, okay, I have 2, 3, 4, 5 days before it. Do you still think if you think all the information from the days before, the 4 days before it, is contained in the very single day before it, then it's irrelevant to put all those predictors in a model, right? Because all the information is contained, right? When you talk about longitudinal data analysis and that kind of stuff, like if all the information didn't matter about like anything past this certain date, past like 3 visits ago, then that's not going to really affect your prediction for this next event, this next outcome. Right? I don't know. The PhDs is like, what do they call it in martingales? It's like some non-stationarity state. I don't know. I don't know statistics really. That's how I just like, whatever. We'll call it something. There's something in martingales about that. But really, I want to. Okay. I don't know. It's something where like after a certain time, that doesn't matter with respect to the expected value for something. Whatever. Who cares? We're not talking about that right now. So long. That didn't work out right. Let's see. Okay, so what I'm trying to do is make this super long data frame. Okay, so I say as.data.frame. So, I'm just going to recall it the same thing. So, doesn't have this like time series property, doesn't have any of that kind of stuff. And if I say the row names, right, it gives me a date. Okay. For the next 5 minutes, I'm going to assume what I'm doing up here. If anybody doesn't understand what I'm doing, they're going to stop me. Okay? So what I'm going to do right now is just make a column that's called time. That's like the row names. Okay. Now, super wide data set became super long data set. Okay? Now, if you only care about the open and closed data, This is a highly inefficient process. Right? We have five symbols that we're doing here. And this is more about optimization and the kind of questions you'll get for like a data science interview in some respects. Like, why is this inefficient?
Sorry, why is what?
Okay, let's say, so we did this for 5 stocks,
Yeah.
right? Why, for example, now I'm going to subset the open and close prices on this long data set. Why was this inefficient? So I have all these columns that are irrelevant, that I don't actually need, right? Adjusted, I'm not going to use. Like high, I'm not going to use. Close, I'm not going to use. So actually, that reshaping process, although it was very quick on my machine, if you can think of billions and billions of rows, right? When it's even wide and you make it long, it's like trillions of rows maybe now. Like you should probably drop those columns before doing reshaping. Does that make sense? Like again, these are, I mean, if you do it. So somebody tell me right now the code to give me the number of rows of each data set. Of each stock. How many days are given?
Aren't they all the same?
Tell me. I don't know.
Well, it's just the number of rows of multi F before you.
So L apply, D2, and row. ABBV does not have all those rows.
Wait, I don't understand what you're saying.
So I did
D2,
over the list. D2 is the data frame. Is not an environment. It's a list. Right? It's the converted list. So this is how it's going to go from the next 10 minutes. I'm going to go around in a circle. Whenever I ask code, you're up next. Okay? Just to kind of get, I don't know, people talking other than me. I want Jordan to talk. That's really what it is. I want Steven to know when it's coming. Okay. So, just a reminder, D2 is the list. Data was the original environment. We're not working with that thing anymore. All DF is the merged big data frame. That's super wide. Okay? Okay. Jordan. What are we going to do? Code to subset only the open and closed columns.
From
D2. All right, here. Head D2. Okay. Any kind of, so either using column names and grep or like dplyr functions or whatever.
I would lean towards using column names and grep.
Okay, so it's a list. So what are we going to do? What are we going to first start with?
L
Lapply. Perfect. I'll define a function on the fly, and I'll call it x. So what am I doing with x?
grabbing the column names of x and choosing the ones that have.
So let's do this. Let's say, just so we can test some of your code, right? Gives us that. Great. So cn stores those things. Now what?
So you want to grab the ones that have open and close in it. So
How about instead of grep, let's try have you guys, I don't know who's, never mind, I thought there was a str find. Maybe that's false. Match? Have you ever tried those? Anyway, let's use grep. That's fine. Grep. What's my regular expression I'm looking for?
open or close.
Okay. Say value equals true. Oh. Okay. So grep looks for this string, open, the pipe says or, and you pass it what you want to look for. Value, here, let's do this. Grep will give you the indices for that object. Value will actually give you the strings. In this case, it's somewhat irrelevant, but okay. What do you want to call this? So just, it's fine.
Then
Something like that. Okay? Does that make sense to everyone? So then there's like, you can also do, I'll show you just quickly the, I think you can also technically do that with dplyr stuff. Nope, maybe not. If it doesn't like that, say. One of the problems with doing it like this, I know I kept the rows. Okay, same thing. Select has a whole slew of different functions. If I were to start R all over again, I might look deeply into dplyr, but I'm not starting R all over again. So, okay. Now, I'm going to use Jordan's answer.
Is there a reason that you did that on the list instead of doing it on the data frame? Like just taking a subset of the data frame? Like is there
No, but usually subsetting and merging is more efficient than merging than subsetting, because the merge operation can be kind of a workhorse. But that's a good point. You can do that on the data frame as well.
I just don't like lists. That's why.
Don't like lists.
No.
Okay. Not many people do.
Understand them.
Okay. Now, here's a better question. Do we even want this? Do we care about how much? So, here's the thing. Are you more likely to buy an expensive stock or a cheap stock? I don't know the answer. But the question is, if you're going to predict the change, right? Do you care how much it costs? This is not like, I don't know if there's an answer to this, but I don't know. I think you should explore that, right? That's an idea that, like, although you're trying to model percent change, be like, is it over $5 at open? Right? That's like a thing to maybe think about. So we may want open, we may want close, but do we really care about? We really care about this ratio, right? Close divided by open. So we probably want to make that when the data is together. So we want to do that stockwise, right? So the list of data frames is actually a really good way to do that, right? If you say like, hey, D3, got to close, got a column open, that's for that specific stock. Because after you merge it, then you have to figure out like open, divide by close, all that kind of stuff. You don't want to do it that way. So it's probably better to do the things on the individual data sets themselves, right? To create this predictor. Does that make sense?
It's better to do stuff like that.
Yes. I mean, how else would you do it?
Like we can not do just a of like hundreds or thousands of markets and take a relative value.
Sorry, say that again? So,
You can use it as like a lot of stock markets value for open and close and combine them to do a time series analysis. And then I don't know, like fix a model and then predict it between individual stock values.
yeah, so like, for example,
Because that
Sorry. You're saying, sorry, what do you mean confounders?
Like the factors that could be that its individual stock value
Mm-hmm.
or the ratio of the close divided by open,
Mm-hmm.
and then because some the confounded values which could be affect every stock value in US, then we don't have to use predictors.
Yeah, so remember what we were talking about with PCA, right? Like you want to be able to identify. So I think I get what you're saying, and I think that's a great point. That like if let's say on average today was a bad day,
Yeah.
right? So like yeah, that's my whole point. So this value though I think is the but whether you want to look at putting as a predictor other things, right? Like, not only do you care about maybe this stock's up or down, right? Because if yesterday it went up or went down, that might be great. What if all stocks went up? What if all stocks went down, right? Is that what you're kind of getting at? That's, yeah, so that kind of adjusting for the entire market or for all, for the rest of the stocks is like a surrogate, right? I think that, so that's why I kind of talked about PCA in some respects, because you can kind of get trends of kind of what's going on in the market. So, what I'm saying is, if you got the ratio to be like 1.1 or something, to predict, you may want to adjust for the fact that like, if this stock was like 1.1 yesterday, maybe also what was the average for yesterday, right? The average gain of all the other stocks. So the big difference is that this comes down to the modeling question, right? Will you do a model for each individual stock, right? That will assume only information about that stock, right? It's not going to have anything to do. It's going to leverage no other information over the other stocks. Or are you going to do one big model, right? And I mean a big model in the sense that each row represents one day of one stock, right? Does that make sense? Like, you could do a single, like you can do a individual stock model, right? Like I want to know the stock of AAA or 3M, sorry, right? I could do a model on all the data I have for 3M for the past like couple of years, right? But you don't leverage any information about the rest of the stock market at that time. So it's kind of depends on what you're doing, but in general, you use the rest of the data. In general, you would do a model where you combine with the rest of the information because that'll allow you to kind of leverage population level things kind of going on. And not necessarily like just putting the rest of the data in there doesn't account for the fact if like the rest of the stock went up yesterday, you'd have to put a predictor in there, right? That kind of indicates that, like a lag global measure.
Yeah, the first thing I thought about is that if we assume that we use kind of moving average something, then the time lag we use in predictors that depends on the industry sector. For example, in financial market, they change it quite dramatically than the other sectors, so we use the different time lag in the time series model. So we could use, even though we use a really big model, we could adjust the effect of that factor in the model. So in that case, even though we have one model, we could use different weight to different sector of industry.
Mm-hmm.
That's what I thought at first.
So the other thing is, so let's say now you have the data where it's like let's say for these 500, you have 500 rows and some level of time, right? So you can standardize it in some way where you can actually run PCA and actually get a score for that day, right? In the sense like if it's it's going to be a little bit confusing. In the sense, what I'm trying to get at is how to potentially create predictors that account for global changes.
The first one is the industry sector. That's
Like the mean or the median or like what for that? I'm saying like,
that's
Like-
a factor, right?
yeah, that could be one of them. It could be, so I'm saying using global and industry specific factors are probably a really good idea. Huh?
I haven't thought about it.
No, I mean, well, it seems like you have. I mean, you thought a little bit, right? I mean, so I'm saying though, like, thinking about how to account for changes overall, right, is an important thing, right? Like that the market's going up, the market's going down, which isn't specific to this stock. So some stocks go up, some stocks go down, but if the overall market is going up, like, how do I want to phrase this? It's like just because if like everybody was going, let's put it this way, if everybody was going down, right? The whole market was shifting down. Like people were just like stocks were losing money. Then you might not like penalize a single stock like to be like the one you are going to predict because it's going down because everything else is going down too, right? If it's going down, like yeah.
I guess I'm confused because all it really matters is your prediction for that stock. So like, at the end of it, you're still going to be comparing all the predictions for the stocks to pick the stock. So then, why does knowing what everything else is doing matter? Because when you get to the end, you still make a decision.
So if you put in a model, so okay, let's talk about predictors really quickly, right? Let's do that for like 5 minutes. So what are you thinking of putting in here? Like probably the percent change from the day before, maybe 2 days before, right? Maybe 3 days before. And what about like the average change? I'm just like thinking about ideas. So Eugene gave us some good examples of ideas. Steven, what other predictors, features would you think about putting in a model?
What we have available.
Or creating a lot.
Why are you asking me? Yeah, I'm asking you.
Corner.
Quarter?